Hello, my friends. Thank you for coming to our session, 5 Ways to Make Kubernetes Spark Joy with Quarkus. I'm Edson Yanaga. I'm a Java champion and a Microsoft MVP. And currently, I work as a Director of Developer Experience at Red Hat. And today, I have the pleasure to present a joint session with my friend Ray Tsang for the first time. Ray, introduce yourself, please.
Yeah, hello everyone. My name is Ray. I am a developer advocate at Google for Google Cloud Platform. And I'm also a Java champion, and it's an honor to be able to present with Edson for the very first time as well. And for the first time, we are actually, on the same screen, so you can actually see that we're two very different people, just in case you mistaken us for one another.
Yeah, this is proof that we are not the same person. Some people mistake us for each other, and you might be arguing that just because it's video, because we could be editing, but we'll be able to show that live after this pandemic is over.
So what are you going to be talking about today, Edson?
Okay, so we know Ray is a Kubernetes person and I'm a Quarkus person. So let's make the best of both together. So for us to begin this session, we need a Quarkus project. So what we're going to do, we're going to our favorite website on the internet these days, which is quarkus.io. And if you go here on the top right side of the screen, you're able to see this button, big button, Start Coding. So as I click here, you can see my generator. So I'm just going to type, the only boring part is for me to provide the group ID, which is going to be com Red Hat developers, and artifact, which is Kubernetes Spark Joy with Quarkus. And generate my application. You can see that you can download the zip file in your machine, but I'm going to push to GitHub because we want to collaborate on the fly. I'm recording from my home. Ray is recording from his home, and we want to make it super easy for you. Yes, my supersonic subatomic app is ready. So I'm going to click here. You can see that my code is already available on GitHub. And I'm going to share this URL with Ray. But before that, let me try here the settings. I'm going to collaborate so we don't have to keep using pull requests. So I'm going to manage access here. It's going to be super dangerous. I'm going to invite a collaborator. So Ray has this very nice GitHub login Saturnis. Ray, you're invited, and I'm sharing with you my repo URL.
So thanks, Edson, for giving me the repository. So what I'm going to do first is to just check it out. So I'm going to go ahead and git clone the entire repository. Okay, and I can cd into it. And this is my application. Of course, I can go ahead and build it with a Maven package if I want to. Just make sure I have everything downloaded. If I want to run it, I can also just use the Quarkx dev command so that you can run the application in dev mode. Okay. But now, given that we have this application, what we want to do first is to create a container image so that I can deploy this into a containerized environment like Kubernetes. Okay. So there are many different ways of doing this. One way is to use a Docker file, and that's what people usually do to get started with because it's easy to understand what the Docker file is doing. However, it's also very easy to make a mistake with Docker file. Now, Quarkus actually gives you a Docker file out of the box. If I recall correctly, this is in your source, man, and Docker, right? So here, Quarkus already gives you the Docker file. However, both of us have the same friend in Okta. His name is Matt Rabel, and he's also a Java champion. And what he always say is, friends don't let friends write authentication because authentication is repetitive, it's mundane, it's also error prone. And it's a very similar thing for Docker file too. You don't want to have lots and lots of these Docker files everywhere. And also, it's really hard to actually apply all the best practices to a Docker file. You actually need to learn quite a bit more and also have some experiences with this. So what I'm going to say is, friend don't let friend write Docker files. So rather than using a Docker file, you can also use some other tools that automates this entire process for you. So for example, Google has a project called Jib, J-I-B, and with Jib, it will actually analyze your entire build from a Maven or Gradle perspective, and then generate the optimized container image for you without you having to write any Docker file. And the good news is Quarkus actually have this built-in as one of the extensions you can add as one of the mechanisms to build a Docker image. So the way that we can do this is by adding an extension. So what I'm going to do is just use the Maven command line. And I'm going to use Quarkus plugin to add an extension. And the extension name is just called jib. Okay? And what this will do is to configure my Quarkus application to be able to build a container image with jib. Now, before I can, I'm going to stop here for a little bit, and I'm just going to open up the application and then resize the window. Okay, so pause. So once this is ready, we can go ahead and containerize our application. However, we need to instruct Quarkus to tell it like what is the group name, what is the image name that I want to build. And then we also need to tell it to maybe build the container image every single time by default, so that when I say Maven package, it will just automatically build the container image too. Now I can pass it in via the Maven -d command line here with the additional configuration like Quarkus.container-image-build is equal to true, right? But if you have to specify every single time, it is a little time consuming. So rather than doing this, we can actually just add this into the application.properties file. So I'm going to go ahead and open up my application. Okay, so now my application is opened up in my IDE, and I should be able to go to my resources here. And in the application.properties here, you can then specify a few more attributes so that you don't have to specify it every single time you're trying to rebuild your application. So first of all, the first thing that we're going to add is to tell Quarkus to always build a container image whenever that I'm trying to do a package. Okay, so here I can say Quarkus container image build is equal to true, so that we'll always build the container image. However, once I build the container image, I may also want to just push it to my registry. Okay, so for example, if I'm not running this container locally, I want to push it to the registry so my remote Kubernetes cluster can also get the same image. In which case, we can just say Quarkus container image.push is equal to true. However, what is the name of this container image? Well, Quarkus will give you a way to also configure this. Basically, it's broken down into three parts. Which three? Well, first of all, there's the registry name. So, like, are you pushing to Docker Hub or are you pushing to another registry? So, for example, on Google Cloud, I can push this to my container registry, GCR. So, for this, I can set it to gcr.io. And then there's the group name. So this is just a sub-organization under the registry. So on Docker Hub, this may be your username. Like for me, it would be Satanism. Or it can be a project name that's on Google Cloud. So basically, it's a registry / something, and then Quarkus will automatically generate the application name for you. So that is the structure of your container image coordinate. So we can configure all of these things too. So for example, the first thing I need to do is to make sure I'm using the right registry. So I am going to be using gcr.io, that is a Google container registry. And the group name for me, I need to use a project ID that is specific to my project, which happens to be Wise Coyote 287. And just by doing these two things, I should be able to now create my container image and then pushing it to the remote registry using jib. Okay, so what I'm going to do is go back to my terminal and rebuild this application. Okay, so now I can go ahead and rebuild my application, and I should be able to just do maven w and package. Okay, and let's see if this works. We're building my application. It's doing some tests. There we go. And now jib is coming into play. So here we can see it's using base container image. That's default with jib. And then I push the container image to the remote registry underneath my Google container registry. And now it's ready to go. I can even try it out if I want to. So I can say docker run ti-rm and then give it the entire thing. And it's going to download it from my remote registry, and my application should be running in a second. And there you go. Done. That was pretty awesome. No Docker file, and just a few configuration, then we're off to go. Well, that was pretty easy to just create a new container image. So, Edson, what's next?
So I just got race changes from GitHub, And now I want to deploy that to Kubernetes, but to Kubernetes, we need YAML files. And who loves YAML files? Yeah, me neither. I'd like to say that friends don't let friends write YAML files. So if you don't want to type all of that YAML stuff, how can I do that in a way that sparks joy with Quarkus? So the easiest way for you to generate your Kubernetes YAML files and OpenShift YAML files too is by adding the Kubernetes Quarkus extension. And how do I do that? If I go here to my project, I can do Quarkus list extensions. You're able to see a lot of extensions that we have available, but the one that we're particularly interested, you can see that it's a lot. I'm scrolling here, but if I want to add an extension, I type the magic words, which are Quarkus add extension, and I type extensions equals to Kubernetes. And yes, this process just added dependency in my pom.xml file. And if I want to see the YAML file that is automatically generated by Quarkus, I just type again my magic words, mvn package, and I get these properties, quarkus.container-image.push equals to false, because I don't have the race credentials for his registry, for his private registry. That's why it's private. But if I just type this, and once this command finishes, we're able to see the Kubernetes YAML files that were generated. So running the test. And it's done. Let's go to the target folder. You can see here that we have the Quarkus application, but if I go into this folder, Kubernetes, you're able to see that I have a Kubernetes JSON and a Kubernetes YAML file. Let's inspect this Kubernetes YAML file. And Quarkus generated a Kubernetes service account, a Kubernetes service, and a Kubernetes deployment with the data that Ray provided in his application properties file. And that's what I had to do. Now let's try to commit this code. I'm going to push this to GitHub, and I'll hand over back to Ray because he has more features to show to you. Ray, what's next?
All right. Well, let me go ahead and try to check out the code. So I'm going to say git pull. There we go. I think I got your changes. And let's go ahead and see what you actually generated. So I am going to run Maven package as well. And now you can see how this is nice because without doing anything, I can also reproduce the same YAML file. Okay, so let's make sure this package goes through. And now we have pushed the container image. And now if I go back to my IntelliJ IDE, then what I will be able to see is under target and classes meta.inf, this is the YAML file that I should be getting. Actually, it's right here, sorry. So that looks pretty good. Now, from a Kubernetes point of view, this is a pretty complete YAML file that's ready to be deployed. Like right here, this is the deployment, and it automatically added all the labels for me. Okay. And what is really nice also is the image. Remember the container group and the registry names and the application name. That's all auto-populated here. Okay, so that is pretty neat and awesome. However, before you deploy this, there are a few more things you have to watch out for as you progress into Kubernetes for a production environment. One of the most important things for a containerized application is that you have to adhere to the orchestrator's application lifecycle hooks. Right? What that means is that Kubernetes needs to know whether your application is alive, and if your application failed to respond to this liveness check, then it will automatically restart the application for you. This is one of the benefits of Kubernetes, to be able to automatically recover if your application is not responding, right? So to do this, you have to create a liveness check. The other thing that Kubernetes will do for you is to serve your application when it's ready. What does that mean? If your application is alive, shouldn't it just be ready? Well, that's not always the case, because if your application is alive, it doesn't necessarily mean that it's ready to serve the first request. Why? Because your application might be preloading some data, it's warming up the cache, or maybe it's trying to establish a connection to the backend, to the database, right? And so before all of those things are ready, you don't want to have any requests coming to you. And Kubernetes can do this via something called the readiness check. Okay? Now, usually you have to type this thing out in this YAML file, but with Quarkus, you can also use the same mechanism to auto-generate the liveness check and the readiness check. Now, for this to work, you have to add some kind of health check to your application. And so I heard and I learned that this is also easily done with Quarkus too. So in Quarkus, what you can do is to, again, add an extension. And the extension that you want to add is the small RAI health check. So you can use the same mechanism here using Maven Quarkus add extension, and then you can say you want to add the small RAI health check. And what this will do is to configure your application to be able to respond to a health check that has the readiness check and also the liveness check. Okay? And to see the updated YAML file with the health check, rather than you writing it yourself, all you have to do is just repackage your application, and when the new YAML file is being generated, it will have all the health checks pre-configured for you, so you don't have to write it yourself. We gotta speed these things up. There we go. Okay. Okay, so the application has been recompiled, and also the YAML file has been regenerated. Now, if I go back to my IDE, check it out. It automatically refreshed, and here's my health check. And this is the endpoint that Quarkus can actually respond to. One very important thing to remember here is that for the health check, for the liveness check, it should be a simple check against your application and your application only. What that means is that your liveness check should not actually check for downstream dependencies, right? Because imagine if you have a database that's having an issue and your application's liveness check depends on the database, and when the database goes down, your application's liveness probe goes down, and then rather than fixing your database, Kubernetes will try to restart your application over and over and over again, and that's not really helpful. And so for this type of checks, that checks for downstream availability, sometimes it's better to have them in your readiness check instead. And Quarkus actually does this. So in Quarkus, this readiness check will automatically check for the status of some downstream systems. Like, for example, if you have configured Quarkus to use JDBC driver to connect to a database, if the database is not working, if it's down, it will actually trigger this readiness probe to go down as well. And now your application will no longer serve any request. It will be taken out of the load balancer. And then the upstream applications will no longer be able to reach your app, and they will have to handle this failure on their side very quickly, right? And that's a very simple way for you to add health checks to your application. So what's next?
Thank you, Ray. Let me get your changes here. So yeah, that's the wonder of distributed development with Git. So I have Ray's changes, and next step is, well, we have liveness and readiness pros, but maybe I can't allow my application to consume all the resources of my clusters. So whenever you're trying to deploy applications to Kubernetes, it's a good practice for you to limit the resources that your application can consume in the cluster. Also, when you're trying to schedule your application inside the clusters, it's a good practice for you to see, well, what are the minimum requirements for my application to run successfully in the cluster? So we're going to declare some Kubernetes resources requests and limits. And for me to be able to do that, of course, I'm going to use the Quarkus Kubernetes extension that I already have available. Let's try to make this build run again. So I'm going to run here. Run, generate the YAML. You can see me downloading the extensions. I'm going to generate the YAML file again. Awesome, it's done. So let me open back here my IDE. So if I go here, you can see that in the target folder, Kubernetes, I have the Kubernetes YAML file. So if I want to customize the YAML file that is generated with additional properties, what I can do, I can go back here to my project. So under source main, I'm going to create a new folder called Kubernetes. And on this folder, I'm going to copy the Kubernetes YAML file that was just generated so I can customize it. So I don't need to customize the service accounts nor the service. So the only thing that I'm interested into is the deployment one. And the deployment one here, I have the spec template. And at least on this version of Quarkus, you can expect like soon to have even more stuff. I'm going to put here, so I have the image pool policy. Let's try to add some resources. So if I type it correctly, resources, and I have requests, and let's try to request memory. This is a Quarkus application, so it should be super lightweight. So I'm going to request only 64 megabytes. It should run in less than that, but let's be generous. So it's going to request only 64 megabytes of RAM, and for CPU, it's going to request only a quarter CPU. And for the limits, let's put some limits here. Limits memory, I'm going to put some 96 megabytes of RAM, and CPU, let's use like half the CPU. And that should be good. So I just added the YAML file, and it's going to check because the other properties are generated by Quarkus. So Quarkus, just in case you change anything, is going to reflect that. If you change the group name or the image name here or the register name, Quarkus is going to update automatically. But Quarkus is also going to check that this custom part, the resource request limit that I just added, well, this is a custom thing, and it's going to add these properties on the Kubernetes YAML file that is generated in every build. Let's see if it works. So I go back here to my terminal. I'm going to clear here and run the MVN package again. And if you think it's slow, please have in mind that we're recording a lot of different stuff right here. I have a video conference application open with Ray. So yes, everything takes longer when you're watching it. Yes, build success. Let's go to my target folder, Kubernetes, and I'm going to get the Kubernetes YAML file. Let's see if I have these properties. Yes, you can see that the Quarkus Kubernetes extension add these properties in the bottom. So you can see the resources, limits, memory, CPU, and just in case I made a mistake, I had a typo, the build would fail because the extension would check, well, this property does not exist, so you have something wrong. So yeah, the Quarkus Kubernetes extension doesn't allow you to generate an invalid Kubernetes YAML file. And that's what I had for now, but we're talking a lot about Kubernetes, but we didn't see it running on Kubernetes yet. So Ray, can we deploy this to Kubernetes?
Okay, thanks, Edson. I see that you want me to do the deploy, but what if it doesn't deploy? Then all of a sudden it's my fault now, isn't it? That's a pretty evil plan of yours, but I'll take on the challenge. Okay, so I have pulled down the changes already, while Edson just right after he pushed it. And we need to do another rebuild. So here we go. I'm going to say maven w and package. And in this case, I'm just going to skip the tests because of the time. Maybe it'll be a little faster. There we go. And it will try to recreate the container image as well. And we're done. Okay, so now let's just go ahead and double check the work. So I'm going to go back to the IntelliJ IDE. And here is the generated resource from Quarkus. And ideally, here we do have the resource limit and the request. And what just occurred to me is that one thing that's really important to remember is that this file that Edson just added, it gets merged into the final generated file so that the differences are merged in here. And now we have the request and the limit. And it's pretty amazing that the memory resource is just 64 megabytes. That's pretty low, but I'm pretty confident that this will start for this Java application. So let's go ahead and try to deploy it. I'm going to go back to my console and try to deploy this file. So I'm going to say kubectl apply -f. From the target in Kubernetes, I have the, oh, there we go. In Kubernetes, I have the Kubernetes YAML file. Now remember, there are two files here. You just need one of them, either the JSON or the YAML. I like YAML for now, so there we go. So now it actually created three things for me. There's a service account, which you can use to restrict additional access from your application to Kubernetes. This is a very good security feature. So you can configure the rules that what your application can do within Kubernetes using the service account. It also created a load balancer so that we can load balance between multiple instances of the backend. And finally, the deployment is the application itself. And let's see if everything's up and running. So I can say kubectl get pods, and we can see that the application is being started right now. And eventually, the application started, and now you can see because of the readiness check, once the readiness check passes, now the ready is 1 out of 1, then we can actually try out this application. If I go ahead and take a look at the service has an internal IP address. This is the load balancer, but it only has an internal IP address. So we can connect to it just because we want to show you everything's working. Then what I can do is to establish a port forward. And what does that look like? Well, you can use the Kubernetes command line here, and you can say port forward to the service code. Oh, not that one, sorry, to the service code Kubernetes Spark Joy with Quarkus. And then you can bind your local port, this is the local port, to the remote port of this particular load balancer, which has a private IP address. Okay? So I can establish this port forward, and now I can go to my localhost 8080, and I should be able to see this application. Okay? And just to show you what that might look like, I'm going to go ahead and do this in my console as well, in my browser. So, ta-da! 1 second, let me pull a browsing here. Okay, so now to show you what this application looks like in Kubernetes, I can just go ahead and go to my localhost 8080. And remember how this works? This is actually going to my local port, but then port forwarded into my cluster, into that load balancer, and then routed the request to the actual backend. And we have only one instance, and now we're seeing the Quarkus application up and running. That was pretty awesome without having to write any Docker file or even most of the YAML files. Okay, so what's next?
Okay, next we're going to show you dev mode, and better than that, remote dev mode. So let me show you some magic here. I'm going to type the magic words here on my local machine, mvn quarkus -dev. So Quarkus is going to start in development mode, so it's listening for changes in my machine. So whenever I send a new request here to my local machine, Quarkus restarts and does that in a supersonic way. So it's already running. So if I go here to my local browser and type localhost 8080, yes, my new cloud native application is running. If I go to hello, yes, it's replying hello. So let's go here to my IDE. I'm going to open the hello resource, example resource, and let's try to add another endpoint. So I'm going to open here, public. I'm just going to copy paste, it's easier, right? So it's going to be 6 lines, copy here. I'm just adding another path. Sparks Joy. And the method is going to be Sparks Joy 2. And return Kubernetes Sparks Joy with Quarkus. I just saved the file. I go back here to my browser, and it's automatically refreshed. Let's go to our new endpoint, Sparks Joy. And yes, Kubernetes Sparks Joy with Quarkus. But suppose that I want to test this application or try to develop this application using my Kubernetes environment. Because when I'm localhost, I don't have all of the dependencies that I would have in my cluster. And so if I have my development cluster, I would really love to have this development mode experience where I just save the file and everything is automatically updated. So how can I achieve that using Quarkus? Because Quarkus sparks joys in development mode both locally and remotely too. So I just need to change some properties. So I'm going to go back here to my application properties file. And the magic properties are quarkus.package type. I'm going to use immutable jar just for me to be able to change the application on the fly. And I also need a password. Quarkus live reload. Password, I'm going to say sparks joy. And that's it. I'm just going to now go back here to my terminal, stop, and let's see if it works. MVN clean package, and remember, Quarkus container image dot build equals to push equals to false because I don't want to push to raise a registry. Let's build in again. Running the tests. And now it's done. Let's see the target folder. You can see the target folder. Here we have new folders, Quarkus and Quarkus app, but we don't have to be worried about that because again, our Quarkus Jib extension will generate the Docker container image beautifully with everything enabled for remote development mode. But for that, we need to redeploy our application to Kubernetes. So Ray, can you do that for us?
Okay, now in order for Quarkus to be activated in dev mode when you deploy it into Kubernetes, you actually need to have a special flag, and this flag can be passed in with an environment variable. The variable is called Quarkus launch dev mode, and you have to set the value to true. This is because if you launch your application normally, you don't want anyone to be able to just replace the application right and constantly look for the changes. So what we need to do is to configure our Kubernetes YAML file to add this additional environment variable for development purposes, only for development purposes, right? And to do this, what I'm going to do is to edit the source, main, Kubernetes, and Kubernetes YAML. Now remember, this file is used so that we can use the changes here to merge it into the final generated file that's under the target Kubernetes, okay? So whatever changes that you made, so for example, the resource request and limit, these changes get merged in. So what we're going to do is to add another environment variable so that we can set this value. And here under inf, we can just set a new name to Quarkus launch dev mode. And then for the value, we're going to set it to true. So once this is done, what I'm going to do is to just go ahead and recreate my application and regenerate the YAML files again. Okay, so now everything has been regenerated. Let me just double check the final Kubernetes YAML that's being generated. And in here, we should be able to see the merged in changes here for the dev mode to true. And I should just be able to redeploy this. So I'm going to say kubectl apply -f target Kubernetes and Kubernetes.yaml. And this should restart my application and start it in the dev mode. Let's double check. So you can see the new container that's being created. And once it starts running, the previous older container will be replaced. Okay, now the application is up and running again. This is now running in dev mode. So now you can do local development, and when you change something, it should actually show up in this container automatically. So to show you this, I'm going to hand it back to Edson.
Thank you, Ray. Now the application is running in remote development mode. I just pulled the changes from Ray and I'm ready to make the magic work again. So let me open here. I'm just going to open my application properties file. I'm going to disable the build and push because we want to speed up the things here. And that should be good. So now I'm going to type the magic words mvn quarkus instead of just dev, remote-dev, and I'm going to put the URL here, quarkus.live. Reload URL is going to be this particular one that Ray just gave to me. I have the IP, I have the port, and when I type here, remote dev is going to connect to our Quarkus application running on Kubernetes, and once it is connected, any change that I perform here locally is going to be reflected in the remote cluster. So right now it's already connected. Let's try this application. I'm going to open here a tab in my browser. And yes, my new cloud native application is ready. Let's try to open that particular endpoint, sparksjoy, hello/sparksjoy. And you can see here, yeah, Kubernetes sparksjoy with Quarkus. But let me try to edit this file locally on my machine. So I'm going to change this string here and say something like Ray. Yes, it really works. And save the file. As soon as I save the file here, let me switch to the logs. You can see that we have a change. And as soon as I connect and refresh, Quarkus is already updating the application on the remote Kubernetes cluster. So if I send a request here, I have an internal server error. Oh, it was a glitch. So yes, I think it was just updating. No, yes, Ray, it really works. Ray, can you open a browser in your machine and check if it's really working for you too?
Yeah, let me give it a try. So what is really cool is that in my log, I was able to see the hot replacement taking place too, and the application restarted in just a few seconds. Now, if I want to show you what I see here on my machine, I can go to the browser. Let's see. Okay, so in the browser, I'm just going to go to the same URL, which is a hello/sparksjoy, and yes, it definitely works. That is really, really cool that you can edit something locally and then automatically replace the application in the remote, speeding up your development loop cycle. Awesome.
I hope you are convinced that Kubernetes really sparks joy with Quarkus. Actually, Kubernetes sparks more joy if you're using Quarkus. So let's try to remember the tips that we presented for you today.
So first is that friend don't let friends write Docker file. If you can generate a Docker file, or better yet, use an automated tool like Jib, do that so you don't have to write the Docker files yourself.
And since nobody's YAML file, friends don't let friends write YAML files. So you should be adding the proper Kubernetes extension so your YAML files can be generated automatically.
And before you go into production, make sure you have health checks configured. Add the health extension, and so that the liveness probe and the readiness probe can also be automatically generated into the final deployed YAML file by Quarkus.
And you don't want your application to consume all of the resources in your Kubernetes clusters. So make sure also for you to complement your YAML file, specifying the resource requests and limits, how much your application needs and how much memory or CPU, the total amount of memory CPU that your application can consume.
And finally, to speed up your development in Kubernetes cluster, make sure you check out the Quarkus remote dev mode. That looks pretty awesome, the way that Edson was able to edit the file locally and then replace the application in the remote cluster.
And that's it. I hope you enjoyed this session just as much as I did, and Ray, I'm certain that about that too. Thank you all and stay safe.